Hey, Aubrey. We are doing a little like second half, whatever, of 4.3. We started log functions. So on Friday, we talked about logs and exponentials and switching them back and forth between the two. And now we're going to be graphing logs, which is kind of a pain in the rear end, but that's okay. I'm going to, so at the top of this page, do you see where the two little boxes are? At the top of this page, let's talk about the exponential function. So I'm going to write exp up top here, and let's go like y equals 2 to the x power. That's an exponential function, okay? And I'm going to graph what he looks like, okay? If you remember from exponential functions, he will always hit here, unless we move him around. He'll always hit here at 1, right? And then he'll go like this, whoop, okay? That's what he will look like. And he'll have a horizontal asymptote here and all the things, right? Okay, but if I flip him over, like we said that logs and exponential functions are inverses of each other. So if I take him and I flip this guy across that line, what he will do is he'll go like this, right? Where he'll have a vertical asymptote and he'll cross here at 1, 0. This is the log function and this is the exponential function. Do you see how that works? So a log, you can see him down here better. He will cross at 1, 0 instead of 0, 1, and he will have a va instead of a ha. That's what a log function will look like. So he's like separated down the middle, and he's you know, goes down to infinity forever, and then he like loops out. Okay, crossing at 1, 0. That's what he will look like, unless he is an x or he is a base that is smaller than 1, like the exponential function. Let's say we have y equals 1/2 to the x power, okay? That guy we said was a decay function. He's going to still cross at 0, 1, but he's going to go this direction. If I take that guy and I flip him, he is going to go, now his vertical asymptote's here. He's still going to cross at 0, 1, but he's going to go like this. Oh, gosh, that's not what I wanted. He's going to go like this, okay? So if it's an exponential decay, these two graphs will like crisscross with each other. If he's an exponential growth, they will not cross. That'll be like an H kind of thing that's being made, okay? Versus this guy is going to crisscross with each other. So log base 1/2 will cross here at 0, 1. He'll go like this. He'll like go up to infinity forever, and then he'll kind of loop out like an exponential function.
So what is
okay?
The green is?
So the green here is the exponential function, 1/2 to the x power, and then the blue is the log. So it's just flipped over, like log functions will just look like that. Yep. This is 2 to the x power, is the blue right here, and then the green is log base 2. So he will look like that. So he makes an H if it's like a base that's larger than 1. They will crisscross each other at that dotted line right here. They'll crisscross each other if it's a base that's smaller than 1. Whatever. That's what logs look like. Yeah. Okay. All right. So example 3, log base 1/2. We just kind of graphed that guy. I'm going to really quick in black. I'm just going to graph what 2 to the x power looks like. His inverse, not 2 to the x power. The inverse of log base 1/2 is 1/2 to the x power. Okay. And 1/2 to the x power, I know is going to cross here at 0, 1, but he's going to go like this. Zoop, and he's going to have a ha right here, right? He's going to go out forever and out forever, okay? The log function, so log base 1/2, that's what we're trying to graph. I'm going to graph him in green. He's going to cross here at 1, 0, but he will have a vertical asymptote. He'll just suck close here, and then he'll go like this, whoop, something like that. So the green one is the one that you want to graph. The other one was the exponential function, but it helps me to graph the exponential function before I graph the log. Got it? So the green one is the right one.
Do we need to label which one is which?
Sure, if you want to. Like, it's helpful for me because I have different colors. 1/2 to the x power is this guy. Okay? And they are flipped across this dotted line, y equals x right here. They're like mirrored. Okay? B says log base 3 of x. What's the inverse of log base 3 of x? 3 to the x power. So if I go 3 to the x power, he's going to, I'll graph him in blue. He's going to cross here at 0, 1, but he's an exponential growing function, so he's going to do one of these, right? Okay, he's going to have a horizontal asymptote, okay? But the green one, I'll graph log base 3 in the green. The green is going to have a vertical asymptote. He's going to cross here at 0, 1, right? But he's going to go down forever, and then he's going to go out like this. He's going to make like an H, right? Okay. They won't cross each other.
Where do you see
They're
this
reflected.
H?
I don't know, like the Hurley. Do you know the Hurley brand? Hurley. Have you ever seen Hurley?
It was very confusing when you did miss H, but it's irrelevant.
Hurley. You know what I'm talking about? Like the Hurley brand. It's an H.
Like this one.
I got it.
Got it? It's in Hurley H.
I got it.
Whatever. Whatever.
Sure.
Okay. Whatever. Anyway. So there's that. So if it's a number bigger than 1, he makes the Hurley H. If it's a number that's less than 1, he will crisscross and do like this little pattern thing. Okay? Got it? But then they start to do this stuff. Boo. Okay. All right. So I'm going to graph what he normally looks like right here. Oh, gosh. That's not what I want. Okay. Normally. Oh, my Lord. Oh, my Lord. This is 2, this is 4, this is 3. So they're all numbers that are greater than 1. And so they're going to cross right here at 1, right? And they're going to, all of them are going to do this, right? That's what they will look like before we move them around. Now, what is the 2, the 3, and the 4? How does that like change them?
Taller.
Like it's going to make like this would be 4 and this would be 2 and this would be 3 and all the things, right? Like it just depends on the steepness of him. Okay, I'm not real picky about that. But now let's talk what this guy's doing. How does this guy move him?
Right one, right?
That moves him to the right one. So this dot right here will go here. His vertical asymptote will be here, and he will go like this. Okay, so let's talk domain and range for him. Domain, range.
To the left forever, to the right forever.
He won't go to the right forever, though. Or he won't go to the left forever. He'll go to the right forever. But he won't go past this line.
So
Greater than 1.
So x has to be greater than 1. Okay, what about range? Up and down.
All reals.
That guy's all reals. Okay. Okay, B. How does this guy move him?
Which one?
B.
Down
The
one?
minus 1. That moves him down 1. So I'm going to go back to the blue one. I'm going to move him down 1, right? So he's going to cross there. My vertical asymptote still stays at the same spot, but he's going to go like this, and he's going to go like this. He's moved down 1. Okay?
Wait, hold on.
Yep. Yep.
They saw the same photo.
so
Yeah.
it's the same
So domain, range is the same domain and range as the original guy. So his domain, left and right, the x will have to be greater than 0. The range, all reals. Okay, now this dude. What color should I go in? Let's go in green for this guy. This guy's moving him how?
To the right, left 2,
Left 2,
up 1.
left 2, up 1. Okay, so I'm just going to start with this dot, and I'm going to move him to the left 2. 1, 2, and up 1. So he goes like this. Okay, left 2, up 1. That's where the dot is. Where's the vertical asymptote at?
Hold on. Left.
negative 3.
Negative 2. He's at negative 2. And it goes like this. Okay.
So x is greater than negative 2.
So domain, this is for part C. Domain, range. X is greater than negative 2. Range, all reals. Can you make sense of that? Is that a mess? Quite a mess. Quite a mess. I think I have you do like some matching or something on that. So hopefully it's not too much graphing. I think I do make you graph a couple of them, but it's not terribly difficult. Okay. All right, let's do some properties real quick of logs. Let's talk properties. Okay, there are, I don't know, like these 3 properties right here I'm going to illustrate. Ready? You see this little box. I'm going to put an example off to the side over here. Boop, boop, boop. Okay, product, property. Here's the product property. Okay. Let's say we have, I don't know, log base 2 of, I don't know, 10x. Okay, log base 2 of 10x. All right, 10 and x are being multiplied together. But multiply in log world means
Divide. Add.
add. Okay, so if I want to pull those apart, it will be log base 2 of 10 plus log base 2 of x. That's how it works in log world. Okay. Now, the reason why multiply means add, if you want, you don't have to write this down if you don't want to, but like, let's say I have like x squared times x to the 3rd power, right? Here I'm multiplying the x's, but what do you do with the exponents? You add them, right? This would x to the 5th. So multiply means add when it comes to exponents. Same thing with logs. Logs and exponentials are inverses of each other, so multiply means add, okay? So if I want to break those apart, it looks like that, right? Okay, now, quotient property, let's say I have, let me do the same thing again. Let's say I have log base 2 of 10 over x, right? I'll put him in parentheses maybe, okay? If I want to break that apart, 10 and x are being divided. Divide means subtract in log world, okay? So for example, the reason why that is, it's let's say I have x to the 5th divided by x to the 3rd, right? I'm dividing those, but what do you do with the exponents? You subtract them, and it's x squared, right? So divide means subtract, all right? So in this log, this will be log base 2 of 10 minus log base 2 of x. That's how that works, right? Okay? All right. This is my favorite property. Let's say we have like log base 2 of x to the 10th power, right? Okay, there's a little rule that says anytime we have an exponent here and there's a log in front, you can come down. Like 10 log base 2 of x. Do you remember that being a thing? Okay, let me show you why that is. Are you ready? Okay, here we go. Did you get that written down? I'm going to come show you why that is. You don't necessarily have to write this down, but let me show you why that rule applies. Okay, we have log base 2 of 10 times 10 times 10, right? Okay, and let's say I want to break these 10s apart. Multiply, the 10s are being multiplied, but multiply means add, right? So I have log base 2, well, no, let's go before that. Log base 2 of 10 to the 3rd power means 10 times 10 times 10. Got it? Okay, so this is log base 2 of 10 plus log base 2 of 10 plus log base 2 of 10, if I split them apart, right? 10 to the 3rd power means 10 times 10 times 10, right? But if I separate those into like the pluses, so log base 2 of 10, log base 2 of 10, log base 2 of 10, you see what I just did? How many of them are there? 3. This is 3 of the log base 2 of 10s, right? So that's saying this is the same as this. That's why I can bring that 3 down in front. You see why that is? Okay, so that's the justification for that rule. Got it? Okay. All right, and then the last one says this. I'm going to just use their example. So logarithm of 1 and base a. Okay, so let's talk about this guy. Let's say I try to switch him to an exponential function, right? This would say a to the 0 power equals 1, right? Anything to the 0 power is 1. So if I put a number in here, this could be any number I want it to be. As long as this guy is 1, this guy will always be 0 because anything to the 0 power is 1, right? So this is like saying, let's say log base 2 of 1 is going to be 0. Log base 8 of 1 is going to be 0. Log base 100 of 1 is going to be 0 because anything to the 0 power is 1. You see how that works? Okay, so that's what that is illustrating there. This guy says, if I say, let's say I have log base 2 of 2 equals 1, right? Okay, if I rewrite this as an exponential function, this says a to the 1st power equals a. Well, duh, right? 2 to the 1st power equals 2. Log base 7 of 7 equals 1 because 7 to the 1st power equals 7, right? Log base 100 of 100 equals 1 because 100 to the 1st power equals 100, right? Okay, so no matter what, I could change these numbers, but as long as these two numbers match, they kind of like cancel out and they create 1. Got it? When they cancel, okay? So that's like kind of a shortcutty thing also, okay? Woo, are we snowed yet? No, not too bad. Okay, here we go. Use the properties of logs. I give us a lot of room down below here, so I'm just going to expand them below. So A, log base 6 of 7 times 9.
The adding one.
So we're going to add. So he will become log base 6 of 7 plus log base 6 of 9. And that's all they want us to do is just separate them out. Okay, so that's A. B is division.
Minus
So log base 9 of 15 minus
log 9 of 7.
log base 9 of 7. Okay, now they're going to get a little bit harder. Ooh, C. What the heck are we doing there?
Square root, probably dividing.
No. Because there's not 2 pieces. There's only 1 piece. It's 8, right? But what's the square root mean? Like as an exponent. Half. This is like 8 to the 1/2 power. Do you see that? Now what do I do with that thing?
Move the 1/2 to the front.
Move the 1/2 to the front. So the 1/2 comes down in front. So it's 1/2 log base 5 of 8. And that's it. Right? The 1/2 comes down in front. Okay, interesting. D now. Let's fiddle with him a little bit.
Can we move the 3 to the front?
Kind of. But he's already got a 2 there, right? So what's the cubic root mean?
M to the 2/3.
This would be the 1/3 power, right? But there's already 2 there. So this is like m to the 2/3 power, right? And then what?
Move that to the front?
The 2/3 can come to the front, right? Okay, so 2/3 log base A of m, right? He can come to the front as well. Holy moly moly.
Log A.
Okay, how many pieces do we have on part E?
5.
A lot. 5 pieces. Holy moly. All right, now here's the deal. Okay, we're going to get to a weird thing, and I want you to, like, be careful. All right, so all of these at the top are being multiplied, right? And all these these 2 at the bottom are going to be multiplied as well, right?
But then you need subtraction in the middle.
Okay, so let's see what we got there. Well, look at that. I love it when you bring me sugar. Let me grab my pen. You can just leave them up. Well, it doesn't matter. There you go. Thank you, sir. Thank you, sir. You want to just punch him and set him back there? Thank you so much.
Whoa, you should make us meetings.
I know they're so jealous of me when you bring stuff to me. So good.
You just need to order like 6 of them one day.
I know. I think they'll only let me do it once, though. That's the only problem. Okay, E. All right, we have 5 pieces. Oh, we want to separate these guys. Okay, so first chunk will be log base A of what?
M.
M. Hold on. Log base A of M. I want to separate the N and the Q. So it will be plus log base A of
Q. N.
N plus log base A of
Q.
Q. All right, and then how do I do the bottom guy?
Minus.
Minus log base A of
Piece. Put the 2 in the front.
P squared, right? But we want to put the 2 in the front, so I'm going to put 2 here, and I'm going to not put the 2 there. Can I do that? That's like all in one shot.
So then same thing.
All right, now here's the problem. Here's the problem.
It's being multiplied.
T is being multiplied by P, so is this add?
Sure. Probably not actually.
Okay. If we do add, that would be log base A of
4.
T, or we could put the 4 in front, right? So I'm going to put the 4 here, right? Okay. But here's the deal. Because both of those are in the bottom, I'm going to do this. Okay? So the minus is out in front of here, and both of those 2 are in the bottom. So it's saying, like, multiply these guys first before you put them in the bottom with the negative. Or what you can do is you can distribute your negative through. So that will be minus 2 log base A of P minus 4 log base A of T. You see how that works? Because they're both in the bottom, both of them need to be minus. Got it? So you can write them like this with the plus sign between them, saying multiplied, but both of them are in the bottom so that they have to be minus in front. Do you see how that works? That's the funny business. Okay? All right. Blah, blah, blah. F is also kind of a doozy. Okay. All right. What shall we do for F? This is kind of gross.
Let's just move the N to the front to start.
The end of the front. Okay, but this is the end. Hold on. This is the nth root. So this guy is to the 1 over n power.
We're gonna have
Right.
other stuff to probably
So this 1 over n, let's just toss him in the front and let's not worry about him anymore.
Yeah.
Whoop, 1 over n. So what I'm going to do is everything is to the 1 over n power.
So put parentheses.
So I'm going to do like a big old fat bracket, right? So everything's to the 1 over n power, and then I'm just going to like deal with him later. So we have 3 pieces, right? We have x's, y's, and z's, right? Okay. So log base b of
3 in front though.
x, and she wants to put the 3 in front, right? So that's x to the 3rd. Okay, then what?
Plus.
Plus 5. Mm-hmm.
Base B to the Y.
Log base b of y. Yes, exactly. Okay. Then what?
Minus
Minus.
M.
M's going to come to the front. Yeah.
Log base B of Z.
Log base b of z. Awesome. That's good. Yep. Oh, I'm gonna do bracket. Okay, and then the 1 over n is just chilling in the front.
Yeah, that's just a mess. Those, when you get all those number or letters,
What?
like, I hate when they do letters.
I know,
Log
I know.
B of Y to the.
Yeah.
Just have letters and just have numbers.
Right. Mrs. Allen always brings, like, she used to bring her kindergarten class in here all the time, especially when I was helping her coach volleyball. And she was like, and this is the teacher that messes everything that I do up, because she's like, I spend all kindergarten year saying these are numbers, these are letters. And then you get to Mrs. Comercher's class and she just throws them all in together as one. I'm like, yeah, that's kind of true. I kind of undo what she does, right? So whatever. Okay, that is separating. Now, in this next one, which is kind of blurry, it's gonna make me sick looking at
We can
this.
do that tomorrow.
They want us to shove it together.
Yeah, that looks like
That's a tomorrow project.
Yeah.
All right, I'm fine with that. We only have 2 examples left.
We got
Then you have
lots
time to
of-
work
we got
tomorrow.
lots of
Okay,
homework to
that's
do.
fine. I'm not too worried about it. All right, goodbye, Aubrey.